A question that gave everybody a hard time last year was that about an explorer trying to swim across a river. It says that the river is flowing 0.665 meters per second. And the explorer can swim 0.723 meters per second. And we have to figure out what angle to the water he's going to have to try to swim at. Well, we know that he's going to have to oppose the motion of the water to get directly from one side to the other, because the shortest distance between 2 points is a straight line. So we know he's going to have to kind of go at a severe angle into the water flow to keep from getting pushed downstream. So his swimming velocity is going to be the overall total velocity, the magnitude of his velocity vector. But we know that 0.665 of it is going to go in the x direction here. Because if his velocity relative to the water is any less than that, he's going to get pushed at a velocity down the river. If it's any greater than that, he's actually going to be swimming upstream. So what we have so far in the ideal situation that we want is him swimming with a maximum velocity at some angle, and the x component of this velocity should be 0.665, opposing the current in the river, and then we'd be left with some y component. And we could draw this y component of his velocity vector such that these three vectors make a rectangle. So let's start to figure things out. Okay, what are we trying to figure out? The angle with respect to the shoreline. So that would be this angle here. So this is our theta that we're trying to figure out. So let's look at a triangle. Here's a triangle, and let's blow that thing up and put it over on the side. So we got this triangle. The hypotenuse is the overall magnitude of the guy's velocity, and the x component of his velocity represents this side length here, which is 0.665, and this side over here would be the y component of his velocity, which would be the velocity which with he's actually crossing the river. And then to figure out theta, well, we don't need to figure out Vy just yet, but we can use cosine to figure out theta, because we know an adjacent side length and the hypotenuse. So CAH, C-A-H, that means cosine equals A adjacent over hypotenuse. And then you have to use the inverse cosine to figure out the actual angle. And on your calculator, that should be a button with cosine to the -1 power of that value. So that will give you the angle theta down here. And once you know that, there's any number of ways to figure out this side of the triangle. You could, for instance, set up this equation using the definition of what sine is and the theta value that you found for the angle, and then solve for Vy. Or you could use the Pythagorean theorem, or if you wanted to get really crazy, you could even use tangent of theta. And once you find the y component of the velocity, we know that that must be equal to the y component of the displacement, delta y, over the time it's going to take to go the whole way. and we can just solve this equation for delta t, and that'll give the time to cross the river. And that delta y is the just the distance from one side of the river to the other.
Made with Doodlecast Pro.